Okay, this next example looks at um, a situation that's referred to as one of Zeno's paradoxes. Uh, a paradox is something that's seemingly uh, true but also impossible at the same time. Okay, so Zeno made several of these. He was a Greek philosopher, uh, and this comes about around about 450 BC, give or take. He lived about 490 to 430 BC. And we know about his paradoxes through the works of Plato, Aristotle, and other commentators that came later. Uh, and so he was trying to posit the idea that reality is singular and unchanging. Uh, so he came up with this idea that Achilles, if he was in a race with a turtle, so here's the situation. Now I'm going to put some numbers in this so we can talk about it. So Achilles is able to run at a speed of 5 miles per hour. Okay, of course, he probably can run further. And for the sake of the argument here, we're going to say that our turtle can run at a speed of 1 mile per hour. It's a pretty darn fast turtle. The argument is that if the turtle gets a head start, Achilles will not be able to ever catch the turtle. And the reason he won't be able to catch the turtle is because they argue that, well, once Achilles covers just continue the problem before I try to explain it. So let's say the turtle gets a 1 mile head start. A 1 mile head start. Then Zeno argues that it's impossible for the Achilles to ever catch the turtle. Because once Achilles covers that 1 mile, then the turtle during that time would have traveled a certain distance. It would have actually been a fifth of a mile. And then once Achilles then covers that fifth of a mile, the turtle would have traveled 1/25th of a mile, right? He would have traveled that, distance again. And the turtle would always travel a little bit further. And so since you're adding up an infinite amount of steps, Achilles is going to take forever because he's going to have to travel an infinite amount of distance. That's the idea. Now, the Greeks didn't have the knowledge and understanding of calculus. They didn't really even have the understanding of zero as a number. So it didn't make sense to them. Of course, they could also see a race and, oh, look, Achilles did catch the turtle. So that's why they called it a paradox. But it's actually not paradoxical with our understanding of calculus. It's actually not paradoxical, it turns out. So here is the question we want to ask, because Achilles will catch the turtle. We want to ask, how far will Achilles need to travel to catch the turtle? Because he will catch him. He will indeed catch him. And so we want to figure out how far he's going to have to travel. So here's the picture. So I'm going to kind of draw it like this. There's some distance. And there's Achilles. And first things first, Achilles will have to travel the 1 mile that start that he got the turtle, right? That has to happen, right? So he has to travel 1 mile, okay? The next leg of his journey, he has to cover the distance the turtle covered while he was covering. What in the heck is one line? I don't know. What in the world? Something I was writing didn't get written down or what? Okay, so now While Achilles was covering that 1 mile, right, the turtle was still moving onward, right, and the turtle would have covered another 1/5 of a mile, right, in that time. Once Achilles covers 1/5 of a mile, then the turtle would then cover a fifth of the distance because his speed's a fifth of what Achilles is. So he'd cover 1/25 of a mile. And then I know these aren't equally spaced properly, but it makes more sense to write it down. The next time, as Achilles covers that 1/25 of a mile, the turtle would have covered 1/125 of a mile, and so on and so on and so on. So what we're seeing here is Achilles would have to cover 1 plus 1/5 plus 1/25 plus 1 over 1/25 and on forever. And the Greeks and Zeno couldn't understand that this infinite sum would actually sum up to something. But we now know that this is just an infinite series. As k goes from 0 to infinity of 1/5 to the k. And so we can compute this because this is just a geometric series. So we know it's a, which is 1 over 1 minus 1/5, which would be 1 over 4/5, which would be 5/4, which would be 1.25 miles. So Achilles just needs to travel 1.25 miles. Since he travels 5 miles per hour, Achilles will catch the turtle in 15 minutes, not eternity, as Zeno unknowingly tried to argue, because again, he didn't understand the idea of infinite series, the idea of a limit. He didn't have any of those things at his disposal. So, but there it is. It'll take 1.25 miles, and again, going 5 miles an hour, he would be able to do that in 15 minutes. He would catch the turtle. Okay, so that's a pretty cool example there, showing that an old Greek idea actually did not have the math to understand it. And there is no actual paradox there. Even though Achilles must go over an infinite amount of different separate distances, he will do it in a finite distance. Okay, so that's pretty cool. It's a direct application of geometric series, and it's neat how that fits into this kind of a problem here.